The purpose of this video is to show how you can do thermocouple calculations with the new update to the SerialDataLogger app. It's popular to use the MAX 6675 K-type thermocouple reader when you're dealing with Arduinos. But if you want a little more control over the measurement, such as having an independent cold junction temperature sensor, or being able to have a different sample rate, different resolution, or interface with other types of thermocouples, you might want to use your own external ADC. The internal ADC of the Arduino and a lot of other microcontrollers is probably not going to be adequate, so you can use something like the ADS 1115, which is a 16-bit analog to digital converter with an integrated programmable gain amplifier. But what I'm going to be using is the ADS 1220, which is a 24-bit ADC with an integrated PGA. So in the sketch that I'm running, I have it set to a gain of 16, and I did a quick calibration, so it should be fairly accurate. So we'll open up the SerialDataLogger app, connect the Arduino, so I have the time in micros coming in the first data set. Then we have the cold junction temperature. That's from the internal temperature sensor of the ADS 1220. And then we have the ADC voltage in microvolts. So I'm going to make a new label, and this is going to be the thermocouple temperature. We're going to operate on the voltage, so that's the third data set. And then we're going to convert it to millivolts because that's what the operation requires. So we're going to divide by 1,000. And now we have it in millivolts. So now we can add the thermocouple calculation. You can see here we can change the thermocouple type. We're going to keep it at a K type. You can also choose where the cold junction temperature comes from. So if we were using the internal temperature sensor of the chip, we could use the CJ data label, but we're going to stick to custom. We could set this to whatever we want, but I'm going to keep it at 0. And since we don't really care about the rest of the digits, there's going to be some noise. I just want to round it to the nearest tenth of a degree. So we're going to add, we're going to first multiply by 10, then we're going to round it, and then we're going to divide by 10. And that will round to the nearest tenth of a degree. Okay. So this is a thermocouple simulator, so it can output a voltage, and we are going to use it to simulate the thermocouple voltage. So you can see there it's set to a K type. Hook it up. So they're both referenced to 0 degrees. it's reading about 0. Let's change it to 100 degrees. There it is. 200, 300, 310, 20, 330. And you'll see it registers changes of 0.1 degrees. Could use a little better calibration, but for the time being, that's pretty good. We can go all the way up to the maximum, 1370. We can also do negative values, so minus 200, so minus 150, minus 145. So that's basically how you can use this app to perform thermocouple calculations. It makes it a lot easier because you don't have to code the coefficients and the equations in the Arduino itself. You can just output the voltage reading from the ADC, and then once it goes to the app, you just select what type of thermocouple you're using, and the app does all the calculations for you.